Hey everyone, how's it going? Welcome to the stream. All right, so yeah, another impromptu stream. It's gonna be like this for a little while. I still haven't figured out a fixed schedule, so sorry about that. Just let me set up here. Okay. All right, so if you've been following last stream, we spent a little time refactoring code, and that went pretty well. Let me see here. Did I? Yeah, okay, that's what we did last week. Just like completely not ready. Okay, yeah, that's right. So last time we did this move sync protocol entirely into debugger, and we split out the emulator core stuff in main CPP into new emulator class, right? If I could just open this. Is it here? No. Hey, Jono, how's it going? So, is this chat showing up on my stream? Anyway, so yeah, so Jono, who is chatting with me right now, he very generously set up a Mac for me, and that I can remote into. So I've started testing that setup out, and it looks like it's gonna work out. So at some point, you know, after I'm done this refactor, we'll be able to focus on, there you go, that's working. Okay, we'll be able to start working on porting Vectrexy to Mac, which is something that's been on my plate for a while, but because I didn't have access to a Mac, it's just something I've delayed. So yeah, so thank you, Jono, for that. Yeah, man, I'm doing pretty good. Thank you. So, okay. So what was it again? Emulator. Yes, yes, yes. So tonight, I'm gonna work on do the remaining to-dos, then reorganize folders. So I'm hoping to get that done. So why don't we get started? Just have a few things to do here. Nothing too big. And actually, you know, hopefully this refactor will even help with the porting effort. I was thinking about how some of the challenges I faced when porting to Linux was things like supporting the debugger and stuff like that. But if I can do this right, I might be able to make it, like what I'd like to be able to do is to have a build where there is no debugger. And I might actually go for that first for the Mac. Maybe. Because I remember one of the things that was kind of painful was, where is it? Yeah, I think, was it this? No, it wasn't this. Okay, I forget now. Just give me a second. I remember I had some code to, oh yes, I remember now, platform. Yeah, this console stuff. That on Windows, the way the console works on Windows is different from Linux, and so in order to get the console to kind of behave in a similar fashion, where is this code again? That's right, line noise. How come I don't have it here? So yeah, so I'm using this line noise thing that tracks history and stuff for the console. So it allows you to do stuff like, you know, press up to go into your history to find previous commands, stuff like that. And these are things that are built into the Windows console, but not in Linux, in Bash anyway, I suppose, or whatever. And I suspect it would be the same on Mac. And I don't know if this library that I got would work. Maybe it would work. Let me see. It might work actually on Mac, so we'll see. But if it doesn't work, then, you know, at the very least, I'd have a version of Vectrexy that just runs and has no debugger, you know, so stuff like that. And then afterwards, we could work on adding support for the debugger, but just to kind of make it easier. Okay, so what did I have here? File system util, merge into file system. Let me see. I don't know if I'm going to do all these things. I just wanted to remind myself. Oh yeah. Oh yeah. File system.h. File system. Okay. Yeah, I'm not sure I'm going to do this, actually. I think what I'm going to do instead, yeah, I think I'm just going to leave this. Forget that. Depend on GUI today, make a GUI CPP to hide this direct dependency. Let's go to that. All right. Okay, so that's what I didn't like about this. Okay. All right. Let's do what I said here. I'll just create a CPP file. Source, name this that. All right, that was the problem. Because it's a template. Yeah. Yeah, so you know what I would need here is rather than use a template, I don't want to use stood function because it's too heavy, it allocates. What I would need really is something that I think they're going to add to C++20, but it is basically a, what do they call it, a function ref. Yeah, I think it's this here. Basically, it's like a function, except that it doesn't allocate. So it's a reference to a function, and it means that as long, you know, similar to the way string view works, it allows you to, let's say, very cheaply pass around functions to you and you know, you don't have to worry about allocations, and that would perfectly work for me. But I don't have that yet, and I don't feel like I'm going to implement it. So you know what? I think I'm going to leave this alone. Because right now, to make this work would just be a pain in the ass. The only alternative I would have, no, never mind. Forget that. Anyway, this was like less important on my list, so I could just get rid of this. Where did GUI CPP end up? So I'll say like need function ref or something to move to CPP. Okay, that was just a note. I wanted to rename this to image util. Let me see. Okay. Make sure that builds. Okay, so that's good. I'll just do it like this. I want to rename regex helpers to regex utils, regex util. Okay. Just wondering why I didn't put this in a namespace. I should have. All right, let's do it. the same thing for string helpers. Okay, this one will be a bit more annoying, but I think it's totally worth it. Okay, two lower. Okay, I think I got all of those. Oh, no, I missed the debugger ones. Here. Okay, I think, yeah, it looks like it's building now. Okay, so this I wanted to hide in the CPP file. Don't need to do that today. We can do that next time. I have already a to-do in here. I need to do this properly for the same reasons I was saying before. I just need to do this in terms of an abstraction for network stuff, but not really worth it. Hey, Jono. So you're asking if I've you mentioned, have you started any projects? So I've not started any projects. I just basically started reading the book. And to be honest, I didn't get really far because at the time I was reading it, they had mentioned that they were updating the book to another version. And I think that they're doing it again or have done it again because it's like Rust 2018 or something. So I sort of put it off until they updated it because I remember I got to the part on how to define modules. It's like chapter 4 or 5 or I don't remember where. And I remember finding it pretty complicated. And as it turns out, I'm not the only one who thought it was complicated because for Rust 2018, they did like a big overhaul of how modules work. And apparently that was one of the most important chapters to kind of rewrite in the new book or something. So I just was like, you know what, I'll wait a little bit and get back to it. But I definitely want to learn it because it's a cool language, you know. It's like there's a lot of things that I'd like to. Basically, the reason I want to learn it is that I kind of want to see what it's like to program something, you know, more serious with the constraints that Rust puts on you. You know, like all the lifetime constraints, having to worry about that kind of stuff. Because from what I understand, when you spend enough time coding in Rust and you go back to languages like C++, it changes the way you'll program in the other languages. You know, it'll change your habits about lifetimes and keeping pointers around and stuff like that. So I'm interested to see what that's like. Have you done any Rust, Jono? That's done. Okay, so I think the only thing I have left to do is this thing here, engine client.h. Spit out types like input, emu event, render context, audio context, and iEngine client. iEngine client should be in engine. Yeah. Yeah, if I don't do this, I won't be able to reorganize my files. But I think this is a good time for me to commit some of these changes here. Did I change line noise? I tried. I'm used to high-level languages, C#, VBNet, JavaScript. I've been keeping up with Ferris, but to get my head around Rust, I tried porting Rustral Boy to C#. It helped me advance my C# knowledge as well. Oh, that's awesome. I've actually been doing quite a bit of C# myself recently because of Git extensions and learning a lot about async await and how to write a GUI application that is responsive and it does a bunch of stuff in the background. It's pretty cool. Okay, so let me just make sure that this is good. This looks all right. Okay, I need to go look at what changed in here. I don't think I meant to change this, so it's probably a mistake. Yeah. Inserted a space by accident. All right, these two I will not check in. All right, so I'm gonna say rename helpers to util and add namespaces. Yes, love async await. I used to use the old method until MS released that feature. So much better than the old callback methods. Yeah, it's really cool. Still, still wrapping my head around some of the things. There's a lot of rules. You got to be very careful. Otherwise, you got to worry about things like reentrancy and the potential for deadlocks is still there if you're not careful, as I've been learning. But yeah, it's pretty impressive how there's just all this syntactic sugar in C#. My network messaging library that I recently open source used to use the old callback method, and once async await came, I migrated to that new feature. Code was much tidier. Yeah, definitely, I can imagine. Do you want me to plug your? If you want to shoot me a link here. Network messaging library. So it's a C# library. What do you use it for? Take a look at engine client here. Ah, yes. ACS messaging. The Advanced Computing Services Messaging Library allows client-server communications. Each instance can be either a server or a client and supports TLS 1.2 encryption. Looks pretty cool, man. Looks nice and clean. So you learned VB.NET first then, and then you moved on to C#? Was that like, because at work you guys were using VB and then switched to C#, or just you wanted to learn it on your own? So what it is that I need to do is, in terms of my dependency chain, is that I have here, like I said last time, what I'm going to be doing is breaking it down into engine, which depends optionally on debugger, which depends on emulator, which depends on core. And right now, I have this one file left where I have, in this one header file, I have types like input, emu event, emu context, render context, audio context. So up here, all these types here, and excluding iEngine client, that are like types that the emulator, you know, this portion needs to see. But engine client does not need to be seen by the emulator at all. This is really only for, it only needs to be seen by, where is it again? Is it main? Yeah. It's part of engine. So it's all going to go into the engine portion of this. So I just need to split that out. But I don't know what to call it. Thank you. Haven't updated in a while, but I want to get back to it. Yeah, VB.NET first. Learned it while I was in training. We had legacy VB6 apps that I maintained, but I did develop some new corp apps with VB.NET. Emma started favoring C# for mobile app development, which forced me to switch over. I wasn't a fan of the syntax. It's grown on me though, and I love it now. That's interesting, yeah. So I actually learned C# when it was 1.0. So like in 2002, like when it first came out, you know. And I was working at a company. This was before I worked in games. So I was working at a company where we made point of sale software, and they actually had their core, you know, point of sale client that would run on machines was written in COBOL. And they wanted to rewrite it in something modern, something that could take advantage of like modern UI and stuff. So they started looking at C#, and that's when I learned it. Now I wasn't developing in COBOL. I was doing C++ there. I was actually writing extensions in C++. I was writing like DLLs because this COBOL environment, which I think was called active COBOL, could call into external DLLs. So I would write like these DLLs with like exported C functions and then implement most of the stuff that it did in C++. But then when everyone was learning C#, I learned it as well, and it was a lot like Java and a lot like C++. So I actually liked the syntax because it was in the same, you know, Simula or whatever style of syntax there. But yeah. But C# has definitely changed a lot, and I've kept up my learning of C# over the years because even in game development, we tend to use C# a lot for tooling. In the different places I've worked, we use C# and Python a lot. Like Python for like kind of, you know, one-page scripts for the most part, and C# for anything a bit bigger than that, especially if there's a GUI involved. And yeah. And yeah, so I kind of like kept up with C#, but then most recently when I started working on Git extensions, which is using the very, very latest in C#, which is what, like, is it 6, 7? I always forget. Anyway, so I've been learning the newer syntax, and I love all the stuff that they've added and that they keep adding to the language. I think I saw recently that they are adding, because I learned F# a couple years ago, and they're adding something to C# that is a lot like what F# does. What was it again? I think it's I forget what they call it, but it's like when you can declare like an enum of different types, but that have, is it that? The union types? Man, I forget. Yeah, 7 or 8. Okay, so what am I going to do with this? What am I going to do? I just need to put these into another file. Come up. First of all, I don't like this name. Input, way too generic. I'm trying to think about maybe if I rename some of this might make more sense. Got this, maybe mu input, mu event, context, render context. Events options. COBOL is super old. I never wrote any COBOL though. I looked at the code that my colleagues were writing, and I knew even back then that I did not want to write any. If you do learn low level, not sure if I should learn C++ or Rust first. I suppose I could do both, but it may not be optimal. I mean, really it depends on your goal, you know what I mean? Rust is growing so quickly, and the ecosystem has grown quite a bit, so you can pretty much do anything. I think Ferris has proven that. Because I was going to say, oh, if you want to write games or something, maybe stick to C++, but that's not quite true, you know, that you can totally write games in Rust. So I don't know. I guess I would say if you're going to spend time learning a language for fun and for more for personal reasons, learn Rust. If you want to learn a low-level language for employment purposes, I guess I would recommend C++, since you're more likely to find a job for requiring C++ than Rust. If that makes sense. Hey, is it Liev? Yep, someone is emulating Vectrex. I guess you're new to the stream then? And someone who actually knows what the Vectrex is. That's always rare. A lot of people come here and have no idea what the Vectrex is. Okay, from the AVGN video. It's funny you should mention that, because I am most recently went on a total AVGN binge, like from the very first episode, and I'm almost done rewatching all the videos again. I love AVGN. For those who don't know, AVGN is the angry video game nerd. This guy. And yeah, he totally has an episode on the Vectrex. In fact, but it wasn't on the Vectrex, right? It was, he didn't have an episode on the Vectrex itself, but just on the games in the Vectrex. And I think it was this one, right? The Star Trek one. Yeah, I think that was the one. Jono, I do like that Rust implements quite a lot of safety that C++ doesn't have, but I know Ferris did quite a bit of bootstrapping when calling other libraries. Don't mind that, doing that with C# at the moment with another project I'm working on. Right. Yeah, that's right. There's a lot of, as you say, bootstrapping or a lot of writing the translation code to be able to access these external libraries. But I do think that there's been a lot of work. Like a lot of people have been writing crates that wrap the most popular libraries. So Ferris does a lot of very hardcore things and kind of things that people haven't done yet. So I think that's why he does a lot of that. But and things like trying to plug his emulator written in Rust in that, I always forget the name there, but that kind of collection of emulators, which is written in C++. So there you have to do the bridging between the two, or for his tooling that he writes with C++ and Rust mixed together. But I think for the most part, if you're sticking to Rust, there's quite a lot of crates you can just use to get what you need without having to do much glue code. Liev, it's some space sim, yeah. Yeah, it's the game Star Trek. Here, you know what? I'll show it to you. I'll show you exactly which game he's playing. Star Trek. Am I running in? I don't know why this one. Yeah, I mean, I've been working on this emulator for a little while now, so. Can't kill this guy. Do you have a Vectrex? How are you finding out the opcode and stuff? Wow, this is really good. Thank you. I do have a Vectrex, actually, but I don't use it to find the opcodes. No, I figured a lot of this out from documentation that's available online. The CPU they use the CPU that's known and documented. So I found documents on it. I found books on it, yeah, it's here. If you want to know the exact thing, it's the Motorola 68A09. Sometimes it's called the 6809. I think A is like one of the revisions or something. So I think it's one of the precursors to the 68000. Yeah, I know, it's a cool chip actually. So yeah, I started with that actually. I implemented the CPU first, and which is all this code here. This took me a long time. And then after that, this I could find a lot of information on. And then the rest of the Vectrex was a lot more difficult to find info for, but there is information out there. And there's one guy who's written probably the best like emulator / game, like Vectrex game development environment, and he documented a lot of stuff on his wiki, so I used a lot of his docs to figure it out. So yeah, if you really want to see how I did it, you could go look at like old streams. You'll see like the first, I don't know what, 30 or something, I don't know what it is, even more. It's me implementing the CPU, and at one point I get into rendering. Yeah, all the videos on YouTube. If you like scroll down on the Twitch page that you're on, you should see like links to everything, and there's like a link to my YouTube section. So I have like all the videos archived there. So this one is episode 98, which is crazy. It means I'm almost at episode 100. Oh no, don't worry about it. It's okay. It's okay to derail the stream. I don't have like a super tight schedule here, you know. Yeah, thanks, man. Yeah, it's been going on pretty long, probably longer than I would normally have spent on this kind of project. For sure, part of what makes it longer is that I stream it, and another part is that because I'm streaming it, I'm kind of pushing the emulator further than I normally would. So, you know, trying to just, for example, like porting it to, you know, it's on Windows, it works on Linux, and I'll eventually be porting it to Mac, and you know, trying to give it a nice UI and implement extra features. And you know, normally for like I wrote a NES emulator, and on that, you know, I spent a lot less time than I did on this emulator, but at the same time it's not as featureful. You know what I mean? Though it does have some cool features, the NES emulator, that I haven't done yet in this Vectrex one. Like I haven't done save states. And my NES emulator, I have save states, but I also have the ability to rewind. So you can like rewind 1 minute of play. So it's something I'd like to eventually do for this emulator as well. Okay, so I think I'm gonna call this, for lack of a better name, I'm gonna call it like engine, either engine types or engine context. I think I'm gonna call it, I don't know, maybe engine types, because these are all types coming from the engine layer that need to be consumed by the emulator. And then maybe I'll rename that later, but that should be good enough for what I need to do right now. Yep, everything's on GitHub. My NES emulator, Vectrexy. All the links should be there. If you scroll below there, I actually have, I added a widget recently. Let me see here. Channel. Oh wait, it's gonna be kind of weird to go to my channel with me streaming on it. Hold on. Can I like... Yeah. I was gonna say that here on my channel, like it's super weird, right, to see yourself on, anyway. Okay, so yeah, I added these, wait, where is it? Oh, I thought I had added a panel here with, oh, I guess it's gone now, I don't know. Weird. I don't know, I had a panel on here with GitHub stuff. I don't know where it went. Anyway, whatever. Okay, so yeah, let's do this. I'm gonna call this engine add new item header file in source. We're gonna call it engine types. construct. Yeah. Okay. Just try something here. Yeah. There's types here that I don't need. I do need array. One feature I really love in C# is because the language is, easy to parse. I love how and it's built from modules. I love how like it can tell you which using statements you actually need, or using declarations or whatever at the top. C++, it's a lot harder, that problem, figuring out which includes are necessary or not. Why do I have so many headers in here? Okay, so that's good. All right, so all this goes. And now pretty much almost everywhere where I have engine client, I mean to use engine types. Okay, screen. This is engine types. Not sure about this one. We'll see. So C++, it's a very difficult problem, the include problem, because of the preprocessor, right? In order for the environment to be able to know which headers you need, it needs to be able to know which macros are currently defined, and the fact that depending on your current configuration or any configuration that you change, the macros can change. It can't know for sure whether types are going to be required, like which headers are required, you know what I mean? Like you might have a header with stuff that's only there if debug is defined, and when you build and release, well, technically that header is unnecessary, but the environment cannot know that, right? So this is the big problem with C++, and it's why there's so much work being done to kind of move away from needing the preprocessor. So all the stuff that's being done with modules, all the stuff that's being done with if const expr, stuff that's being done with reflection, that all these things that are being added to the language are going in a direction and where we move away from needing the preprocessor. And if that's, if we get to a point where we can fully do away with the preprocessor, then, which I don't think will ever really happen, but perhaps what we could say is perhaps there will be situations where modules are being used and there's no preprocessor used, and then in those cases the compiler would be able to say, yes, you need this you'll need this module or you don't need it. But while C++ still uses this old C-style inclusion model with the preprocessor, it just won't be able to do it can be helpful. I've seen features like you wrote a type here, you want me to add the include for that type, that it can do. But saying you don't need this include anymore, that's more difficult, if not nearly impossible. Why did I need this here again? Ah, right. Okay. So now I have GL render. Set focus main window. Debugger needs that. Ah. How's debugger compiling then? Engine types. Engine client. That's weird. Microsoft uses their Roslyn compiler to do that constantly behind the scenes from memory. Yeah, I'm surprised I haven't tried to run something in the background though to try and figure out that out. I guess there are many more pipelines for compiling C++ versus C#, which makes it very difficult. Yeah, so yeah, exactly. It's totally different. There is no preprocessor in C#, right? It's like most languages. Only really C and C++ have this preprocessor pass. All other languages, or most languages that are used, don't have that. They're built in terms of modules. The compiler sees everything. So in C#, everything you see is seen by the compiler. It can build its AST from it. Even when you use, I forget what it's called in C# there, but like what people tend to think is like C++'s macros, like the defined thing, the compiler sees all of that, right? Which is why the code in the, when you do like if, debug or whatever in C#, the code in there, even if you're not compiling debug, has to be valid syntactically, right? So it's because the compiler sees it all. And since it can see everything, then it can do things like figure out what types you require. But that is not the case for C++. Literally, like if I say, if 0, like this line is absolutely not seen by the compiler because the preprocessor will first remove this, and then the rest will be seen by the compiler. So this is bad, right? Yeah, so the thing I don't understand is I have like a function here, like set focus main window. I'm calling it here. Oh, so there you go. Did this not compile before? So okay, so it's not compiling. Good. So that's what I wanted to see. STL engine client. So this is a bit of a problem because I don't want the debugger to depend on it. Yeah, and this is also part of the crappy stuff that I did that I need to fix. Implemented in there, declared an engine client. What about reset overlay? Call from GL render. Just give me a second, I'll be right back. Sorry about that. Yeah, so these are my shitty hacks. Main STL engine. I don't really know what I want to do with this. The problem is that I have these functions that are implemented within the engine, and maybe that's part of the problem. Oh yeah, because of get main window handle. Yeah, it's crap. I think I need to change this. What does this do again? Reset overlay. Oh yeah. Goes through the GL render. I think what I would need to do is add the functions to something like mu context or something like that, or basically the engine becomes a service, right? It runs the emulator, but then sometimes the emulator needs to do something that the engine has to take care of. Right now I'm relying on static linking to figure it out, but that wouldn't work if I truly broke this up into modules. Which I'm not going to do yet, but I might do it eventually. But it means that I have this dependency on the linker to resolve things. And probably the right thing to do would be to, like, I pass these context objects down from the engine down through the emulator, and most of these are just data, but I could expose functions here and say I'm going to pass you down this this type on which is basically like emulation services. Maybe I'll call it emu service or something like that. And on it have a few functions you can call. or engine service, and have like a few functions you could call on the engine, because this way I break the dependency, and then it would be possible to implement it as a module thing. So what I'll do for now is I'm going to move these into engine types. It's not at all the right place because these are not types, right? And I'm going to say to do add these to some type of engine service class that's class implemented callable within Emulator. Something like that. But by putting them here for now, they're visible, so it should work. I think all of this can become engine types. Very little now actually needs to see the engine client. Main needs it, STL engine needs it, and I think that's it. Hey Clown of Fire, how's it going? Yes, the Vectrex stream is back. It's my third stream since I got back. Okay, so let's see if this builds. Looks like it's building. All right. Let's get that checked in. Split out types from engine client into new engine types.h. That's good enough. So I think I should be able now to do the moving of files into their right place. So this is going to be a little bit painful. I wanted to add something here, so I added engine types, right? And that's going to go under here. All right. Just give me a sec. I'll be right back. Yeah, sorry about that. Okay, so where was I? Okay, so I'm going to use my, let's see if I can do this so you guys can watch. Something like this. So this is going to be like annoying because I'm going to have to do a whole bunch of fixing of includes and crap, but in the long term it'll be a lot cleaner. So let's just see how this goes. All right, so technically what we want is we want to have a include directory. What? All right, it's MD. And then we want to have a core folder, emulator, debugger. We're also going to find out if I was right in my analysis. I might have to fix more stuff in terms of dependencies and stuff, but anyway. So those are the 4. And I'll have exactly the same thing in source. directory debugger, emulator, and engine. And let's do this, source. We'll start with include for core. So base will move there, bitops, circular buffer, console output, error handler, GUI, image file utils, or image util because I renamed it. Line, math util, pimple, platform, regex util, stream.h. Okay, and let me go to the source because I have a couple of CPP files in here, right? Image, file, image, and platform is in there. Stream is in there. That's it. Let me see what this looks like. Maybe I should do like one bit at a time. Might be easier. All right. Oh yeah, this is so annoying. Source. It's true that we need to create the folders for each one. Okay, that's okay. All right. And I need to also do the same thing for headers. Here source is, okay, so I don't need to add it there. This is just for creating a source group that I do this. Yeah, that's right. It's called include. Let me see what this looks like. Okay, so there's core for the source, and do we have an include? I don't have an include. Source group. Hey, Bama. Thank you. Yeah, I only recently got back after a hiatus. I'm glad to be back. Trying to remember how this stuff works again. I thought source group was all I needed to do to tell Visual Studio to create these, unless I did it wrong. Include core. Yeah, that's right, Brahim, that's right. Yeah, sorry if I didn't say your name correctly. Include core. Unless I do something else. Let me remind myself what this is again. Source group. For ID project generation, there are two different signatures to create source group. Yeah, maybe I could use this for include anyway. That's kind of neat. Prefix is what? Source groups and files located directly in root path will be placed in prefix source group. So it says tree and then root. So does that do anything? Missing files argument, okay. Files source. I'm not quite sure what the syntax is here. Okay, let's see. Vectrex build include is not a prefix of file. Root. No reload. Huh. I think I've had this problem where doing this doesn't cause the project to actually be regenerated. Could that be? Like if I take this off as an example, or the source group off. See, it doesn't, okay, yeah, so that's the problem. That's annoying. All right, let's see here. So I can delete the cache, but then I need to rerun the command to generate it, which is not completely easy, unfortunately. Yeah, so it's this. Right. There's got to be a better way for me to refresh. Like, I'm gonna have to do this over and over. Still no include folder. Not helpful. What is going on? Oh, maybe, okay, maybe I still need to glob the files. I thought that the purpose of tree was that it would just figure it all out. It says, define a group for, okay, tree, CMake will automatically detect from source, which is here, source files paths. Oh, I see. Okay. I just understood. I see. Okay, let's do this. We need to glob recursively everything under include. How do I do that? File glob, CMake file glob. Glob recurse. Okay. Glob recurse, the variable name, and the relative path. Like this. Okay. We call that include files or something like that. And then we create a tree like this. Does that work? Well, it did something because it regened the project, but it didn't do what I was hoping. Maybe it's because I do need to add it to my source for it to be able to see it all. Let me see. Maybe that's what it is, even though it's not built. So if I go and take my include files here, it's annoying. Unless source. Maybe I still need to put star.star, star.h or something. Finally, okay, there we go. That's cool. So can I do the same thing then for the rest of my sources? Should be able to, right? Like, why do I need to do all this stuff? If I can do it for includes, I should be able to do it for source as well. Just collect all the CPP files. Source, yeah. grab everything under there. Okay, then there's third party. Source shaders. Let me try this here. Oh yeah, I shouldn't call it source files. I should call it source like this. What am I doing here? I'm saying to glob third party for knock. That's the NOC stuff. And then I say set source, but then I do set source again here. That's weird. Okay, it's nothing changed. Okay. Okay, so I think this is better because now as I add folders, they'll just magically appear. And third party, as I'm not on Linux, doesn't show this one. Okay. Hopefully I did not break other platforms, but we'll find out soon enough. So now things should not build in their current state. Yeah. So we'll start with these CPPs here. Ah, right. Something else I need to do is actually add the include folder as an include directory. Yeah, there we go. Do I need to? Yeah, I think I do. Reorganizing is always a pain in the ass. Core platform, like that. And then for stream, similarly, core stream. And now all of these headers that are included everywhere are going to be broken So how do I do this? So I go header by header. Let me see. I can do like replace include or base.h in quotes with core base.h. And similarly for bitops. Yeah, this is boring. Error handler. Oops, got that wrong. This is the fastest I know how to do this, though. Pimple. Okay, we're almost there. So if I did my work right, this should build after all these search and replaces. Platform.h. regex util. After that, stream.h. TCP. And vector2. All right, so let's see if this actually builds. That would be a miracle if this actually builds. $77. Oh. Aha. Relative include. Should not be surprised. Hi, how did I miss file system util? Okay, that's it? Only those two? Alright. Alright. Fix that one, and this one we'll put core. Wow, it builds. And it runs. All right, that's pretty cool. So maybe I'll do this in steps like I'm doing now. Let me take a look at my diffs. There's a lot of diffs. Definitely like this glob recurse. I wonder why I didn't do this earlier. It's like way better. Maybe it's a relatively recent addition to CMake. I don't know. Okay, it's good. And then after that, it's just a whole bunch of renames and lots of changing of includes. What I like is that with the with Clang format doing the sorting, we're going to have all core headers together, and then later we'll have debug headers together and everything. So it'll actually be easier to see the dependencies even just by looking at the includes, which is really nice. Okay, looks good. So let's say moved headers into include source folder. So I don't know if I'm going to do all of this on stream because I think it's a bit long, but let's see if we could just tackle one more or start to tackle one more and see how that goes. Let's do Emulator. So what did I want to do here? Engine client. That moves. Engine types moves. Ah, yes. And then I have private headers that go into source emulator. So these are the public headers. So this is good. Yeah. This is where I get to see, part of the advantage here is the whole private headers that remain together and not visible to everyone. CPU helpers, CPU opcodes, delayed value store, illegal memory device, memory bus, and memory map. PSG, RAM, screen, shift register, timers, and via. Okay. Cool. So here we see the public includes for emulator and the private includes for emulator, or sorry, private source, which includes also its headers. So what's good about this is for these guys, I won't need to actually change the, yeah, I guess that's maybe what I was saying before about always seeing the name. That's only for public headers. For private headers, that won't happen because it's in the same folder. Yeah, well, that's all right. So really then for emulator, I just need to fix includes for engine client and engine types. Oops, I did it again. And that was engine client, and now engine types. Speaking of angry video game nerd, just today I watched the one about Power Rangers. Man, that one was really funny. If you haven't seen that one. Alright, so what's the problem here? Ah, right. Oh, yes. That is a problem, isn't it? Huh. Why did I include these headers again? Oh, yeah. This is emulator. What was I thinking here? Emulator. .h. This is a public header. Yeah. So I made a mistake. Some of these headers do need to be moved to the public part because the debugger needs to see them. Now, at first I was thinking I could pimple this class and move all these things into the CPP file, but at least for CPU, VIA, and RAM, and memory bus, these 4 types, they need to be visible for the debugger to consume them. So you know what? I'll just, let me see here. What should I do? BIOS ROM, CPU, VIA, RAM, memory bus. I think I'm going to end up moving almost all my headers into the include folder, which is okay. It's all right. I think, yeah, that's what it pretty much means. Because a lot of these headers include the other ones. So anyways, let's just see what happens. BIOS ROM. Cartridge. CPU. Okay, I already took care of engine client. Illegal memory device. Memory bus. RAM. And VIA. Yeah, that's what I thought. Yeah, it's unfortunate. I feel that this is what I feared, is that most of my headers would end up moving because, you know, transient dependencies. That's okay. If they're public, they're public. So memory map is one of them. I think I saw CPU, was it again, helpers? Yeah, CPU helpers. And I saw here options, which is something I did not put in my list, and I think it's because I didn't realize that, right, by moving the types into here, I would need to move options. That kind of sucks. Let me see here. Wait a minute. New context. Ah, okay. This doesn't need to be here. That's why. Right. This is not. The emulation context is only required for the engine. Which means I don't need emu events either here. Okay, this is going to change some stuff. Did I move PSG? Oh, okay, no, because via depends on PSG. And screen, and shift register, and timers, yeah. So the whole world moves into there. Okay. Whoops. PSG and screen, so let's do it one at a time. Timers. I wonder if I'll have any headers left that will remain in source. Wait, what just happened? I don't understand. Why isn't it finding timers? Okay, that's really weird. Okay, like I'm going crazy here. It's not finding this line right here. Why? Oh, it's not finding this either. What? Emulator via.h. Give me a sec. I think I need to regen my project. Okay, there we go. Okay, timers like this. Delayed value store, CPU upgrades. Let's see this builds. Right. Right, and this guy needs to include engine client for MU events. And finally, the only header that I had not moved is the last one I need to move. So, all right, well, in the end, I did need to move all the headers, but it's fine. Okay, and it builds. So now we have include with core and emulator, and source with core and emulator. Cool. So let's get that committed. So we want to say something similar. So move headers into emulator. Emulator include in source folder. So we're getting there, not too far. There's really not much left, to be honest. Debugger and then engine. Let's see if we can hammer these out quickly. So debugger will look like this. Source. Okay, so debugger, let's go to include first. So I wonder if I'll actually be able to keep, I think I can keep these ones actually private. So this should work. Debugger header is the only one that goes there. And then for source, we want to move debugger, breakpoints, sync protocol. Hey, what's string util doing here? Oh, I forgot string util. All right, so what we'll do, string util. String util.h. Yeah, okay. And for that, we're going to use a neat little trick that I learned in Git not too long ago, actually. So this should have been part of this commit over here for the core, right? So if I do create a fix-up commit, it does this thing where you can do a git commit -- fix-up, which will do the same thing there. and you specify the commit. Here it's just the UI helps me do it more easily. Oh, actually, there's more than that, right? Because I had to fix up the includes. Let me see. Okay, let me reset to here. Yeah, this might not be so trivial. Let me just take a look at the changes here. Okay, that's string util alone. String util with the rename. Yeah. That sucks. You know what? Doesn't matter. Forget that. Not important. Okay, so back to this. We come to debugger. We have debugger.h. So who includes debugger.h here? That will become debugger.h. And then I think that's it. There's debugger and debugger here. Right, so these headers as well, from the point of view of the debugger, is going to need, yeah, okay, like that. Emulator, core. Did I miss emulator.h? Suppose I did. Thought I moved this guy. Oh, I didn't. That's strange. Okay, engine client wants to open options. Where is this guy? Oh, this guy shouldn't be. Oh, okay, I think that was my mistake. Was I moved engine client here when I meant to move emulator. Okay, so that was my mistake. Engine client does not belong here. That's going to go into right, because I'm supposed to split it out and then put that in engine here. Okay. Let me move this back. Huh. Right. Okay, because it's the header file for debugger. Right, so it's not really private. All right. So I guess these guys are moving as well into the debuggers include folder. Okay, and now I have a bit of a problem with engine clients, because I don't really know where to put this one. Yeah, I'm not sure. Yeah, it's because this actually needs to be visible to debugger as well as engine. Because of that, I might need to add an intermediate dependency, another folder for this. Why does debugger need this again? Oh, because of emu events? Do I use this? Oh yeah, for break into debugger. Yes, okay. That's why. Let me see here. New context. I think my biggest problem is options here. Okay, I think I know what I'm going to do. I'm going to move emu event into engine types. Hey, keyboard got stuck like this. Hello? And then, okay, I'm going to change debugger. Instead of taking emu events, it's going to take sorry, instead of taking, oh no, it already takes Emu events. Okay, so that's good. Okay. So I just broke the dependency of debugger on engine types, engine client, which is what I wanted. Okay. FS path. Oh, crap. Engine client, source. Right. All right, it built. Awesome. So we're like super close now. So what did we do here? We did debugger. And now all we should have left are files for engine. And in fact, what I wanted to do here was call it SDL-GL. For everything that's specific. So some of this is not specific to that, and I might want to move that out. Okay, let's see. Let's start by moving it all in there and just seeing if that builds fine. Oh no, not an include. That was not right. I meant to put it in this in source engine. we got core, debugger, emulator. And then here we have engine, SDL, GL. So technically this should build. Right. There's a couple of relative paths that won't work with the way I did this. Yes, okay. That makes sense. Let me see that. What will I do with shaders here? I guess shaders has to move with the rest. Yeah, that makes sense. And same thing for imGUI impl. Shaders here, that there. There we go. So that builds. And it's possible that some of this should be moved out. Like, I think not everything here has to do with SDL, GL. So for example, engine client here should probably be moved up into the header section for engine, because it has nothing to do with SDL, GL. And I think that's the only thing really that moves out. No. Engine. Okay, let's try that. We move engine client here. GL util, main, options. Options also probably should be moved out. But I'll leave it here for now. Oh, no, I can't, because this guy uses options. So I do need to move it if I put it there. Okay, so let's do that. We'll move options out like this. Even overlays can be moved out. Now I have GL render, GL util, I have the main, and then all the SDL. This makes sense. Everything inside this folder is specific to the SDL GL engine. Everything outside is general, can be reused for different engines. Yeah, that makes sense. So let's see what this looks like now. I'm going to need to fix some include path. Okay, so here we got options. We're going to say engine options.h. Engine client is going to be the same thing. And overlays. Great. And just for for my sanity. Let's try and rebuild in debug, make sure all that builds. I don't see why not. All right, so debug builds, release builds. Cool. This is when I hit Control C, right? Do not break for Control C. All right, this is cool because you see now, I think now if anyone were to approach this code, they would find it a lot easier to understand. To understand the structure anyway. Okay, so let's get this committed. Yeah, so it's a lot clearer, and in doing this process, I was able to break certain circular dependencies that I had, which is really nice because now pretty much everything points into one direction. Like engine can depend on debugger, and depends on emulator. So basically, what I showed here, whoops, engine depends on the debugger here, and it depends on emulator, while emulator only depends on core, and everything depends on core. I didn't quite draw it, but the direction is this way, right? Engine depends on this, this, and that. Debugger depends on this and this, and emulator depends on this, and core depends on nothing. So that's what we've got here, and I think that's pretty nice. So I'm going to push this, although I realized I said moved headers. It's not only headers that I moved, right? There's also source files. Let's just do a minor reword here. So we'll do, what am I looking for? Rebase interactively. All right. Unstage changes. I'll just stash this. So I'm just going to do reword for all of these. R, whoops, R, R, and R. going to say files. And we rewrote history. There we go, move files. So I'm going to push this. And hopefully that builds. And yeah. So we're pretty much done this refactoring effort, which is great. I still have a few more things to do. There's the renaming of the third-party folder, and I want to handle the BIOS ROM properly, put into a data folder. A couple of minor things to fix for packaging. CMake we'll leave alone. Yeah, and then soon we'll be able to work out not needing a debugger. So that'll be for next time. So yeah, thank you very much guys for watching, and I hope to see you next time.